An easy and a seemingly hard problem. So these problems were recommended to me a few days ago on my video. Do not watch this video where I asked for problems by Himanshu, and he is one of the most active members of our community Mathelysis world. Now let's dive into these problems. The first problem is integral from 0 to infinity of g of x e to the power 1 minus g of x. Now, when there are g functions, like we need to know like how we deal with such integrals. Basically, if there are g, we try to break integral into sums in this way. So this integral from 0 to infinity is actually like some function f over here is actually the integral from 0 to 1 plus 1 to 2 plus 2 to 3 and so on. Yeah. So this can be written as sum from I equals to 0 to infinity of integral from I to I plus 1 of f. So we can express integral in form of sum, yeah, and this is helpful while dealing with g functions, fractional part functions, and such. So let us apply that idea in this integral too. Yeah. First of all, let me delete this. Okay, fine. Now this can be written as sum from I equals to 0 to infinity integral from I to I plus 1. And now for the values between I to I plus 1, g of x will be I itself. Yeah. And same over here, the g of x will be I itself. And then dx. Now, this integral is in the world of x, but here are variables in the world of I. So basically, it's just a constant. Yeah, the variables are just a constant. So I e to the power 1 minus I times x, going from I to I plus 1. And now that will be sum from I equals to 0 to infinity I times e to the power 1 minus I. First of all, x is I plus 1, and then I minus I. So basically, we just have 1 over here, and that gives us sum from I equals to 0 to infinity. And we can take e outside, I times e to the power minus I. So, okay, now we have a sum. Yeah. In this sum is basically a arithmetic or geometric series. Basically, here's a geometric series and here's an arithmetic progression as well. So basically, there are some standard formulas to deal with infinite arithmetic or geometric series, which let me derive if you do not know. Yeah, for normal geometric series, if we have a plus ar square up to infinity, and the modulus of r is less than 1, then this is equals to a by 1 minus r. Now for arithmetical symmetric series, we can differentiate both the sides, and that gives us a plus 2 times ar plus 3 times ar square is equals to, if we differentiate this, we are basically differentiating in the world of r. So we will have a times that is minus 1 to the power 1 minus r whole square, and then now if we apply chain rule, we have to differentiate 1 minus r as well, so that gives us minus 1, and the minus 1 cancels out, and that gives us a by 1 minus r whole square, and r should be less than 1. So basically, here's an arithmetic series as well and a geometric series as well. So this is arithmetical geometric series, and it's going to infinite, and the sum is a by 1 minus r whole square. And basically here's also the our common ratio is e to the power minus 1, and the modulus of e to the power minus 1 is less than 1. So we can use this formula. Over here, The first term will just be 0, so we can just neglect the first term and start from I equals to 1 to infinity I times e to the power minus 1. So it will be something like e and then 1 e to the power minus 1 plus 2 times e to the power minus 1 is our a, and then r is e to the power minus 1 again, plus 3 times e to the power minus 1 is our a, and then e to the power minus 2. Yeah, it will be something like this. So we can basically now find the sum is a by 1 minus r whole square. Our a is 1, no, our a is, sorry, e inverse by, and then 1 minus r is e inverse again. So 1 minus e inverse whole square. So now e inverse and e inverse cancels out. That gives us 1 by 1 minus 1 by e whole square. And that gives us e goes in the numerator, e square by e minus 1 whole square. And that's the answer of this integral. Okay, e square by e minus 1 whole square. So this one is actually equals to e square by e minus 1 whole square. Now let's deal with this seemingly hard problem. Yeah, this looks hard, but once we get a catch, like an important fact that we need for this problem, then it should not be hard after knowing that thing. Okay, now first of all let me put a cursor over here and then paste it over here. Fine. Now let me take my pencil. Okay. Or better if I just erase all of this, because there's going to be a lot of cache storage things, and it gonna stop in some time. Okay, so first of all let me delete this, and then let me proceed further. Yeah, the second problem is actually kind of somewhat tricky, kind of, because there's an idea. If you know that, then it's gonna be a lot easier, but without that you may be pondering for a lot of minutes or something like that. Okay, fine. Now again begin. Okay, so we basically have the function f of n as integral from 0 to infinity of x to the power 2n minus 2 by x to the power 4 minus x square plus 1 to the power n. We need to find, and dx as well, we need to find f of 5. Basically let us replace n by 5 first, and then integral from 0 to infinity, that is x to the power 8, yeah, and then by we will have x to the power 4 minus x square plus 1 to the power n dx. Okay, so now when we look at the denominator, if you if you notice that this is actually kind of a square minus ab plus b square. If you notice that it's in this form. Now if we just multiply this by a plus b, yeah, if you just multiply this by a plus b, okay, basically let me just replace n as well. The n over here is 5. Fine. Now if you multiply by a plus b, this is gonna be a cube plus b cube, yeah. And once we have a cube plus b cube form, that is x to the power 6 plus 1, yeah, if we have that, and then it's gonna be really easy because we can apply beta gamma function over there, and the thing that we need to evaluate is just different values of gamma functions. So once you realize that this can be used in this problem, it gets a lot simpler, yeah. So now let's try to do that. So basically integral from 0 to infinity x to the power 8 by x square whole square, sorry, x square whole square minus x square times 1 square plus 1 square to the power 5 is there. So let us introduce let us introduce x square plus 1, so that is a plus b, a square minus a plus b square, yeah, and to the power 5, yeah. So x square plus 1 to the power 5 dx. So now, as I told earlier, this is gonna be integral from 0 to infinity of x to the power 8 1 plus x squared to the power 5, and then a denominator, it's gonna be 1 plus x squared to the power 6, and then dx, yeah. No, 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 not right. So a plus b, it's a cube plus b cube, so 1 plus x to the power 6 to the power 5, sorry, to the power 5 dx. Okay, so now basically we have to make this x to the power 6 as a y, so that we can use Beta gamma function. Let us say y equals to x to the power 6, and y to the power 1 by 6 will be x, and then 1 by 6, y to the power minus 5 by 6 dy will be dx. Then this integrals become, the limit will be unchanged, integral from 0 to infinity. X to the power 8 will now be y to the power 4 by 3, and then y to the y 1 plus y to the power 1 by 3 to the power 5. Denominator will have 1 plus y to the power 5, and dx will be 1 by 6 y to the power minus 5 by 6 dy. Now we can take 1 by 6 outside of the integral, yeah, and then we will have integral from 0 to infinity 1 plus y to the power 1 by 3 to the power 5, and then this will be, this is 8 by 6, so 8 minus 5 3 by 6, so 1 by 2, y to the power 1 by 2 1 plus y to the power 5 dy. Now basically we have to change this into its expanded form to apply the Beta gamma function, yeah. Now the expanded for that will be 1 by 6 integral from 0 to infinity y to the power 1 by 2 by 1 plus y to the power 5. That will be sum from k equals to 0 to 5, and then 5 ck, and then y to the power k by 3. This is basically the binomial formula, that is 1 plus x to the power n is equals to n c k, yeah. First of all, n c is okay, let me write it as sum, yeah, sum from k equals to 0 to n c k x to the power k, yeah. This is this binomial formula. And now we can take these terms inside the sum, because sum is in the world of k and these variables are in the of the form y, so they are just a constant for the sum world, and we get 5ck y to the power k by 3 plus 1 by 2 by 1 plus y to the power 5, yeah. Now we can just take integral inside, yeah. 1 by 6 sum from k equals to 0 to 5 ck, these all are constant for the integral, since the integral is in the world of y. I forgot the dy, and then y to the power k by 3 plus 1 by 2 by 1 plus y to the power 5 dy. Now the formula is integral from 0 to infinity of x to the power m minus 1 1 plus x to the power m plus 1 m plus n dx. This is equals to beta of m comma n, and beta of m comma n is equals to gamma m gamma n by gamma m plus n, yeah. Now for this thing, we will have 1 by 6 sum from k equals to 0 to 5, 5ck. Now this will be, since it's k plus 3 by 2 minus 1, so beta of k by 3 plus 3 by 2. Yeah. And for n, m plus n should be 5. And m is k by 3 plus 3 by 2. So n will be 5 minus k by 3 minus 3 by 2. So that's 7 by 2 minus k by 3. Yeah, because the sum of these two terms should be 5. So 7 and 3 is 10 by 2, 5. And then this goes to 0. Yeah, so this is good. Now we will have 1 by 6 sum from k equals to 0 to 5, 5ck. And this one is gamma of k by 3 plus 3 by 2, gamma of 7 by 2 minus k by 3 by gamma of 5. Gamma of 5 is 4 factorial, so that's 4 times 3 times 2, that's 4 3 bar 24, and 24 times 6 is 1 by 144. Yeah, and then sum from k equals to 0 to 5, 5ck, gamma of k by 3 plus 3 by 2, gamma of 7 by 2 minus k by 3. Now it's just the calculator stuff, but let's try to do it here itself. Now this you can just press this in calculator and you can just evaluate it, but let's try to do. First of all, we will have 5c0. Yeah, and basically 5c0 and 5c5 are same, so we'll just try to write that in the single line. Okay, so basically 5c0, we will have gamma of 3 by 2, gamma of 7 by 2. Yeah, and then for 5c5 as well, the values will be equal. Yeah, for both of them, 5c0 and 5c5. So we'll write it over here itself. Now when k is 5, we will have gamma of 10 and 9, 19 by 6, 19 by 6. And then gamma of 21 minus 10 is 11 by 6. Yeah, plus now we will have 5c1, 5c1, and when k is 1, that is 2 plus 9, that's 11. Yeah, gamma 11 by 6, and over here that's 21 minus 2 is 19. Yeah, so gamma 19 by 6, plus only. Now when this is equals to 5c4 as well, so let's try to find the values when k equals to 4. That's 4 दूना 8, 3 दिया 9, 8 17, gamma 17 by 6, and then gamma 7 21 minus 4 दूना 8, 20 minus 7 13, 13 by 6, plus now when it's 5c2, that also equals to 5c3, so gamma 2 दूना 4, 3 दिया 9, 4 13 by 6, and then 7 21 minus 2 दूना 4, 21 minus 4, 20 minus 3 17, gamma 17 by 6, plus you can notice that these two are actually equal, these two are actually equal, so it's gonna be easier for us to, like, if we find this product, we can find this as well. Yeah? So it's gonna be somehow easier for us. And when it's 3, that will be 3 दूना 6, 3 दिया 9, 9 6 15. Is that 3 दूना 6, 15 by 6. 15 by 6 is actually equals to 5 by 3. Gamma 5 by 3. And over here, 7 21 minus 2 दिया 6, 21 minus 15 by 6. Yeah, gamma 5 by 3. Okay, so now we need to find these values. Okay, now for these values, we can, one thing to note is 3 plus 7 is actually equals to 10 by 2 is 5, which is an integer, Now if the sum is an integer, we can use the formula that we can somehow like reduce this to lower terms, and then use this formula gamma n gamma 1 minus n equals to pi by sine n pi. We'll be able to use this formula, and for this we need the value of gamma 1 by 2 first, which is actually equals to root pi, and this value can be found out by the other formula that gamma n plus 1 by 2 equals to root pi by 2 to the power 2n minus 1 and then gamma 2m. So from duplication formula, try to find the value of gamma 1 by 2, and then using gamma 1 by 2 and this formula, we can find the value of all of these formulas. Yeah. Now let's just delete this for some time now. Yeah, fine. Now let's proceed with our solution. Okay, now gamma 3 by 2. Let's just now find the values first. Find the values. Okay. Now gamma 3 by 2, gamma 7 by 2. For this one, we can first reduce this to lower terms. Gamma 3 by 2 actually equals to 1 by 2 into gamma 1 by 2. And gamma 7 by 2 is actually equals to 5 by 2, 3 by 2, 1 by 2 times gamma 1 by 2. Now gamma 1 by 2 is root pi. So root pi and root pi will just be pi. Yeah, and other stuffs are 15 by 16. 15 by 16 pi. Now the next one is gamma 19 by 6 by gamma 11 by 6. So that is, we can first reduce this to lower terms, and that's 13 by 6, 7 by 6, 1 by 6, and then gamma 1 by 6. And the next is 5 by 6 into gamma 5 by 6. Yeah. And for gamma 1 by 6, gamma 5 by 6, you can use the formula that gamma n, gamma 1 minus n. But let us first of all, let us multiply the other things. Let me use my calculator. 13 into 7 into 5 by 6 into 6 into 6 into 6. That is 455 by 1296. 455 by 1296. And then pi by sine pi by 6. Sine 30 is 1 by 2. So that gives us 455 pi by 1296 by 2. 1296 by 2 is 648. 648. Okay, now let's go to the other one. This is the same. Now gamma 17 by 6. Gamma 17 by 6. Gamma 13 by 6. First of all, let's reduce this. That is just 11 by 6, 5 by 6, and then gamma 5 by 6. And the other one will be 7 by 6, 1 by 6, and then gamma 1 by 6. And we know the product of 5 by 6, gamma 5 by 6, gamma 1 by 6 is pi, just 2 pi. Yeah, and 2 pi times other stuff. So let me directly do that. 11 into 5 into 7 into 2 pi by, so wait by into 7. 11 into 5 into 7 into 2 pi, yeah, okay, fine, by 6 into 6 into 6 into 6 into 6 into 6. That is 385 pi by 648. 385 pi by 648. And now on the last one, that is gamma 5 by 3, gamma 5 by 3. Gamma 5, is it 5 by 3? No, I don't think it's 5 by 3. Is it? It's it. Now okay, when it's 3, okay, so when it's 3, it's, so okay, when it's 3, it's 3 times 2, 6. Now 15 by 6. It actually cost 5 by 2, not 3. 5 by 2. 5 by 2. Yeah, and then only 5 plus 5 is 10 by 2, 5, which is integer. Yeah, fine. Now, gamma 5 by 2, gamma 5 by 2. This one is actually equals to gamma 5 by 2 is actually equals to 3 by 2 into 1 by 2 into root pi, and that is gamma 1 by 2, and the same for the other one as well. So let's square this, and that is 9 by 16 pi. Yeah, yeah. And now let's try to sum these up. Let's just slightly zoom it out. And now this will be 1 by 144. 560 is 1. So that this one is 15 pi by 16. 15 pi by 16 plus 455 pi by 648 plus this one is 561 is 5, so 5 by 144, and then 455 pi by 648 plus 385 pi by 648 plus 5c2 is 5 times 4 by 2, 20 by 2, that's 10. So 10 by 144, and this one is 385 pi by 648 plus 9 pi by 16. Okay, now if we just add this off, so let me add it in a calculator. I think calculator are made for this very purpose, and trying to add it by ourselves is, I don't know, is that helpful? Maybe, I don't know. But if we have calculator, why to do it by ourselves? Yeah, 4 5. But basically, there are also cases of AI, and when AI can do the task, it doesn't mean we do not do it. But still, calculator is easier, and so I'm just pressing these numbers. I'm pressing these huge numbers, and it will take just some time. 385 by 648 plus 9 by 16. Okay, so I added this up, and that gives me 35 by 256 pi. 35 by 256 pi. Yeah, 35 by 256 pi is the answer. So basically, but all of these things like that we did over here were not like hard or complicated. All of these were basically really easy stuffs, but we had to be somehow rigorous in manual. Yeah, the only tricky or let's say process where we had to thought where we had to think was this initial step where we make it a cube. Yeah, where we use the formula of a cube plus b cube. Yeah. So this was it, and the answer for this one is 35 pi by 256. 35 pi by 256. Yeah, 35 pi by 256. Yeah. And yeah, I hope you enjoyed this problem. And the challenge for you can be like without saying that n equals to 5, try to solve it for general n. Yeah, you can try that. It's similar, just some more rigor and ability to deal with variables. Yeah, just try that. And yeah, hope you have a great day ahead. Thanks for watching and keep learning.